we've got to have other ways of solving triangles, finding the legs and finding the angles on triangles besides the standard sine, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You got to have more than that. So that's why we're introducing the law of sines. The law of cosines, because those allow us to work with triangles that do not have right angles. You have questions, you call me, 312-738-1060. If you don't, I have plenty to talk about. All right, plenty. All right, this is so wonderful. And I want to keep moving. All right, let's talk about a problem where we have time for one more problem. Let's go mastery level on this problem. Let's try to look at the kind of problem you could see on maybe a higher level type assessment. All right, let's take a look. Oh, by the way, this is a relevant problem too. It might be the kind of problem an air traffic controller or maybe a pilot would be interested in. All right, so let's take a look. All right, so pray for me as we do this one. All right, so let's say we have a problem. Let's say we have a problem where we say that we have a plane that's traveling at, let's say it's traveling at 300 and let's say 390 miles an hour. 390 miles an hour. All right, 390 miles an hour. Okay, I don't think you can see that. All right, so let's say you're traveling at 390 miles an hour. 390 miles an hour. All right, I think that's a little bit better. And let's say it's a very, very, very bad storm. Let's say it's a very, very bad storm. And let's say that plane experiences a gust of wind that, it's a bad storm, 100 miles an hour. That's a bad storm. All right, maybe a little bit. Let's take it down. Let's make it a little bit more reasonable. Let's say 50 miles an hour. 50 miles an hour. All right, 50 miles an hour. Gust of wind, 50 miles an hour. All right. All right, so that's gonna cause this plane to change course. All right, that's gonna cause this plane to change course. All right, so let's say the result of this plane traveling at 390 miles an hour and 50 miles an hour, the result of each of these occurrences, let's say, is this, what's called a vector right here. All right, so the result of the plane traveling 390 miles an hour and a gust of wind traveling 50 miles an hour is this vector right here. That's going to be a result of the plane flying and then the gust of wind. All right, so let's add a little bit to this diagram. Let's say the initial 390 mile per hour plane, let's say it's traveling at 20 degrees. Let's say 20 degrees east of north. All right, let's say it's traveling 20 degrees east of north, and let's say this 50-degree gust of wind, let's say this 50-degree gust of wind is traveling, let's say that's traveling at 70 degrees. Let's say that's 70 degrees east of north. 70 degrees east of north. All right, so let's say that this is 20 let's say that's 20 degrees. Let's say that's 20 degrees. All right, and let's say this here is let's say that's 70 degrees. Let's say that's 70 degrees. All right, so let's take a look at how we would solve this. What's called a resultant vector. Let's see how we would get this resultant vector using the techniques that we've discussed already. All right, so if this is 20, if this is 20 here, if this is a 20-degree angle here, this angle here, if you drew like a parallel, if this is parallel to this right here, if this is parallel to this right here, and this angle is 20, this angle here would also have to be 20. This angle here would also have to be 20. And if this is 70, if this angle here is 70, and this angle here is 20, all right, so this angle here is 70. This angle here is 70. This angle here is unknown, and this angle here is 20. Maybe what you could do is you could use your geometry skills and you could discover that if this is 70 and this angle here is a 180 degree angle, this angle here has to be 100, forgive me, that angle there has to be 110 degrees. That angle there has to be 110 degrees. All right, this angle here has to be 110. Now, because all of this has to add up to 180 degrees. Now that you know that this is 110, and you also know that this is 20, you know that you have a triangle where all of this is 130 degrees. All of that is 130 degrees. So if I were to redraw this triangle, I'm now working with a 130 degree angle, okay? I'm working with a 130 degree angle, all right? This is 390, all right? This is 390. I'm getting it from right here. That's 390. And this is 50, all right? So that's 390, that's 50, and you got a 130 degree angle. Now you do not have a right triangle. You do not have a right triangle. So none of this applies. We've talked about that a number of times today. None of that applies. And not only that, you can't use your trig ratios. So also what you cannot use the law of sines, because we said for the law of sines, you have to have the angle and the opposite side. You have an angle, but you do not have the opposite side. You have an angle, but you do not have the opposite side. All right, so let's call that A, let's call that B, let's call that C. All right, so you must use the law of cosines. You must use the law of cosines.